Thank you to everyone for joining us for the National Center for Rural Road Safety's August webinar. My name is Jamie Sullivan and I'm the director of the center. Today's webinar is going to be reviewing your road through the lens of motorcycle safety. I have just a few logistics that I'm going to go through with you. Our duration for the webinar will be 1.5 hours. Closed captioning is available and you should have all received a link if you did ask for that, but if not, it is showing on the screen and also can be found currently in your chat pod. Additionally, the recording for this webinar will be available on our website within a week. We have created a new web page where we can house all of these recordings, and that website is up on the screen right now. It's ruralsafetycenter.org/webinar-archive. So you will be able to find it under the training and education dropdown on our website. It is currently under construction, but again, within the week when we do record this one, you should see just about all of the previous ones we've ever had on that web page. Additionally, because we are recording the webinar, we will ask you to mute your phone lines, and we have muted everyone as well on our side. We will have question and answer pods available to ask questions of the presenters, and also please use it to alert us of any technical difficulties you may have. We will have 3 question and answer periods during today's webinar, at which time we will stop and I'll ask our presenters those questions that you have put in the question pod. So again, please feel free to put those in at any time and I'll ask them when we do stop at those 3 sections. We do have a handout of today's presentation available for download. That way you'll have all the resource links that they will be discussing. That's available in the handout pod that you can find on the side of your screen. Additionally, at the end of today's webinar, we will have a survey that we would ask you to complete. You will also receive an email about that survey as well. It just helps us know if these webinars are working out great for you and what additional topics you may want to hear in the future from the center. And lastly, we have been able to create those certificates of completions that we've been talking about. So all of the past ones for May, June, and July have been emailed out at this point in time. If you believe that you should have received one and have not, please reach out to us at info@ruralsafetycenter.org. The certificate should arrive for this webinar within 2 to 3 weeks. In addition to the certificate, you will get a form in case you would like to apply for the CEUs that are provided by Montana State University, and there will be directions for how to obtain that information and how to apply for those CEUs. Again, in order to receive the certificate of completion and the form for the CEUs, you must join us for 75 minutes of today's 90-minute webinar. So at this time, I'm excited to introduce our 3 speakers. We will have Alyssa Guggenhour, Karen Asplin, and Georgine Geary speaking to us today about motorcycle safety. The goal of today's webinar is that once we've completed it, you'll have an understanding of how to review your roads through the lens of motorcycle safety. And in order to achieve this goal, we have several learning objectives. The first is for you to be able to list guidelines for conducting a motorcycle road safety audit. The second is to implement recommendations for roadway geometry, pavement design, and pavement construction and maintenance practices for motorcycle safety. The third is to describe motorcycle safety noteworthy practices for engineering and infrastructure. And the last one is to recognize challenges and opportunities for intelligent transportation systems applications and automated technologies for motorcycles. Our first speaker will be Alyssa Guggenhour. She is a senior project manager with Vanasshang & Breslin, or VHB. For the past 22 years, she has focused on transportation safety, working with federal, tribal, state, and local governments. Her experience includes roadway design, safety assessments, planning, research, and developing education and encouragement programs. She was the former lead of the Road Safety Audit Program for Federal Highway Administration and has led countless RSAs around the country, including those focused on motorcyclist safety. She recently led the development of the new FHWA publication, Pedestrian and Bicyclist Road Safety Audit Guide and Prompt List. And now I'm excited to turn our webinar over to Alyssa.
Great, thank you. Glad to be here today. Right. All right, so as Jamie had mentioned, I'm going to talk to you today about motorcycle road safety audits. All right. So just to begin, I want to talk a little bit about motorcycle safety stats. So, why are we here talking about motorcyclist safety at all? And why maybe you would want to perform a motorcyclist road safety audit. So we know that in 2020, there were over, 5,500 motorcyclists killed, which represents 14% of all traffic. This is the highest number of motorcyclists that have been killed since bars started in 1975. So, we're going kind of in the wrong direction in terms of motorcyclist safety. And in terms of kind of even more recent data, it looks like NHTSA's estimates for 2021 indicate that motorcyclist fatalities may be up as much as 9%. So again, another big increase. So for those of us who work in safety, roadway design, or own and maintain roadways, we have a really big challenge ahead of us in terms of improving safety. Ultimately, motorcyclist fatalities occur nearly 28 more times more frequently than passenger car occupants fatalities that were involved in traffic crashes. So we know that the risk is particularly high for motorcyclists, and we really need to do more to be able to protect them. All right, so in terms of motorcyclist safety, when we think about this in terms of road safety audits, there are some particular needs for motorcyclists that I'm sure some of the other speakers will get into as well. But for those of us when we are performing a road safety audit, we want to consider them because they're more susceptible to the impacts of a crash, as their vehicles provide very little protection. So they are particularly vulnerable to the impacts of the crash. They can also be less conspicuous than larger motorized vehicles and have reduced stability. So we want to think about some of these factors whenever we perform safety audits. So let's get into what is a road safety audit. For those of you who aren't familiar, a road safety audit is a formal safety performance evaluation of an existing or future road or intersection by an independent multidisciplinary team. So what does this team look like? This RSA team is typically comprised of at least 3 members that have expertise in road safety, traffic operations, and roadway design. There's other potential team members that may have a background in enforcement, emergency medical services, maintenance, human factors, transportation planning, motorcyclist safety, any other discipline that's deemed to be relevant to the context of the facility that's being evaluated. So we'll talk a little bit more about how that impacts how we've performed motorcyclist RSAs in a little bit here. But a little bit more about what a road safety audit is that it's a tool. It really helps you to review observed and potential safety issues, to mitigate safety or crash risks. It considers all different environmental conditions and considers all road users. So even when we're performing a road safety audit that is focused on a particular user, we are still thinking about the needs of other users and the potential impacts, so that whenever we suggest enhancements to it, oftentimes we can find mutually beneficial enhancements that will improve safety, in this case for motorcyclists, but also other roadway users as well. And you can conduct these road safety audits at various points during the process. So you can conduct them pre-construction, thinking about the planning and design stages, so that is really sort of a cost-efficient way, so that you know that the roadway that you're building is as safe as it can be, and that you've really taken a thorough look at it ahead of time. It can also be performed during the construction stage. So think about a work zone, or after construction is complete, but maybe before the roadway is opened. Or it can be conducted, as it often is post-construction or an operational RSA, where the roadway is in use, and oftentimes it's in response to a demonstrated crash issue. So why are road safety audits needed? I mean, I think oftentimes, sometimes in our areas of expertise, we think, well, I can take a look at that and determine, maybe some enhancements at these locations. But thinking about why crashes occur, there's a lot of different factors. So, we do have vehicle factors that could be things like the brakes on a vehicle. We could be thinking about the roadway environment specifically, such as maybe sight distance enhancements that are needed. But then there's also a human factors component. Maybe the driver made a mistake or didn't see something that they needed to, so that they couldn't respond in time. And oftentimes, people tend to focus on the human factor side, stating that people weren't paying attention or they were driving too fast, but there's a lot of different reasons why crashes occur. While road safety audits, they very much focus on the road environment, but good roadway design is one that can anticipate and accommodate common driver errors. So thinking about that human factor side of things as well. This concept isn't new. It's been around since the 1960s, when it was much more discussed in the terms of, having a forgiving roadside. But much more recently, it's been thought of as, part of the safe system approach. So for those of you who aren't familiar, this is an approach that has really began mostly in Europe, but has much more recently been adopted by many different agencies, including the federal government here in the United States. Through the safe system approach, as you can see in the graphic here, safe roads are one of the important layers to improve safety, but that there are many layers to this process. And that, we really need to design transportation infrastructure that can accommodate human mistakes and injury tolerances so that crashes or their severity are reduced. So we need to anticipate people's mistakes or understand that humans do make mistakes and that they're vulnerable to the impacts of a crash. So why a motorcycle-focused road safety audit? As I mentioned, the road safety audits can be held focused on specific roadway users or be held just more broadly to improve safety at certain locations. But as I had mentioned, the safe system approach anticipates crashes and focuses on reducing the severity of injuries. And given that motorcyclists are more likely to die or be severely injured if involved in a crash, the road safety audit process can really help us to better understand our knowledge of those crashes, the nuances around them, and to consider the unique needs of motorcyclists when implementing safety enhancements. So how are road safety audits conducted? There's a formal process to this that you can see here on the screen. And I should note that I've also included links below to other RSA resources at the bottom of the slide there, so that you can also go and find more information on each of these steps. I'm not going to go into these in detail today, but the real takeaway here is that it is a formal process for evaluating safety that involves a multidisciplinary team. And using this process, really helps to get to independent and multifaceted approaches to improving safety for the roadway. So I would definitely take a look at some of the resources available on Federal Highway's webpage that describe those in more detail, these specific aspects of it. I should note some of the key items are that, we have a startup meeting to review the data ahead of time. There's a field review component with that multidisciplinary team. There's often a time where we come back and analyze and report on those findings. So we might come back and do a little bit of workshopping back outside of the field, and then presenting the findings to the owner. These are should be conducted independent of the roadway owner. I know many times they aren't. There's, I would say the minimum here is that if the roadway owner is involved, then I would just have it that, the person who, maybe the last person who touched this design or who was responsible for it on that roadway, that they are not involved because they can't really have an unbiased perspective. But ultimately, a team that's independent of the roadway owner is oftentimes best. That information is then presented to the roadway owner, and a formal response should be prepared so that the agency can plan on incorporating those findings, or at least document why they might not be able to. So I would definitely take a look at more of that information on Federal Highway's webpage for additional nuances about each of those steps. Next, I want to talk about some particular motorcycle or road safety audits that have been conducted in the past. As I had mentioned before, I was involved with Federal Highway's road safety audit program. So we held all different road safety audits all over the country with all different roadway owners, whether it was tribal, state, local, federal, and that quite a few of these really did focus on motorcyclists specifically. And because of the nuances around motorcyclists, it was thought that it would be nice to sort of conduct a series of motorcycle-focused road safety audits and then document these into a case study document. So I want to talk about a little bit about each of these, where they were conducted, and some of the key findings from these. So you can see here on your screen that 3 of them were conducted for the purposes of the case study document. So the first one was with North Carolina DOT, and those were in 2 different routes in Graham County, which is near the Tennessee border. The facility type was an existing 2-lane rural highway. And for those of you who might be familiar, it was on North Carolina routes 28 and 143. And we had roughly, close to 5 miles total in the segments that were studied. There's one with Washington State DOT, and we specifically focused on 3 locations on State Route 7, which both has an urban component to it, and then also rural locations that were included. So it was an existing urban multi-lane highway and an existing 2-lane rural highway that was studied. The area covered was roughly about 11 miles. And then the last one was with the National Park Service, and this was at the Blue Ridge Parkway near and south of Asheville, North Carolina. We were looking at an existing 2-lane rural highway and a national park. The total area covered was 60 miles, but we had sort of focused in on some specific areas as well within that 60 miles. So, through our road safety audits, we always want to point out positive elements. Some of the ones we had noted was a strong commitment to safety by many of the agencies that were involved. Also, a lot of collaboration with motorcycle safety clubs and organizations. And that proved to be really beneficial for all of us to better understand the conditions. Also, these are folks that oftentimes were riding motorcycles on these roads and also adjacent roadways within the region. I had a lot of great input on some of the challenges and also some of the positive enhancements on other roadways that we could think about applying to these ones as well. The motorcycle specific safety measures is that there were quite a few of the agencies that had committed to providing these safety measures specific to motorcyclists. So it could be signage, as you can see on the screen on the left there. That was in North Carolina. Motorcyclist education and enforcement was another big one that we had noticed across the board. Looking at installing warning signs depicting unusual conditions that might impact motorcyclists' ability to navigate the roadway. And then also with some agencies using motorcycle pullouts. So on a series of curves, having an opportunity for the motorcyclist to pull over, kind of take a break and then be able to get back on the roadway and continue to hopefully then safely navigate the remaining curves. There were also broader safety measures that were noted that also enhanced motorcyclist safety, such as a reduction in posted speed, providing paved aprons at gravel driveways. That was particularly beneficial thinking about the traction of motorcyclists and providing corridor access management. Right. Some of the challenges that we had noted were just understanding the issue as a whole. I mean, we had crash data, yes, but in some of these areas, they were frequented by people that were on vacation. And so some of those folks, if they were able to walk away, may not have wanted to report the crash because they wanted to continue on their way. And so there was some sentiment that maybe, there were a decent amount of crashes that weren't even being reported in these locations. We also didn't have a lot of volume data, so understanding the context of those crashes in terms of an effective crash rate was also limiting. Understanding the conditions affecting motorcyclists, I think that was another factor for us that could also be a challenge for other people performing RSAs, is that not everyone is a motorcycle rider. And also, so we're relying on research around motorcyclists, which is not nearly as prevalent as it is for other motorized vehicles. And also just, not having that firsthand experience of using that type of vehicle. It was really important for us to have folks on the RSA team who did ride motorcycles and could provide some insights. But that was a challenge for us. Identifying motorcycle-specific measures, again, kind of pointing back to some of the research that had been available at the time or was not available, is that, we had information on effectiveness of treatments, but maybe not understanding fully some of their impacts or, the benefits or, if they did or did not work as well for motorcycles specifically. And also training and licensing, just the variability of that across the board, I think was something that we had really noted, and that many states were trying to tackle and trying to improve, but it's inconsistent from state to state. So you really don't know how well of a skill set the driving population within an individual state might have. So some of the opportunities that we identified through this were really stronger stakeholder engagement. That was something that we found to be particularly beneficial. But I think that's something that just everyone really needs to think about. So thinking back to those motorcycle clubs, or maybe if there's opportunities to get input from other motorcyclists that are traveling within the region. Improve data. I think if we can think about, we're really enhancing the types of data that we all have. And so thinking about the motorcyclist specific data when planning for data enhancements would be great. Improve training for motorcycle riders would be great, especially kind of looking at some of those states that do it very well and some of the states that don't require any kind of training at all, to think about maybe making that more universal and what's required. Enhanced motorcycle specific signage. Oftentimes we're thinking about signs and the application of them from sort of the broader driving public. But given some of the specific challenges that motorcyclists have, it might be beneficial for us to really consider more nuanced application of motorcycle specific signage. And similarly with the application of safety measures as well. Some of the measures that we noted, and I'm just going to kind of wrap up with this as well, is that, the countermeasure side, some of the ones that we had found kind of across the board that were really needed in these locations were things to help to improve the visibility and expectations of motorcycles so that they could see what was coming, so that they could prepare themselves in time, whether that was during the daytime or at night. And so a lot of these you'll find are related to that. And some of the other ones I would say are related to the drivers, the motorcycle riders' ability to maintain their stability or to be able to re-enter the roadway if they happen to leave the roadway, or so that they don't hit a fixed object if they do leave the roadway. So a lot of these are focused on that. So things like safety edge and paved shoulders, particularly on the inside of curves. Evaluating the super elevation of curves for consistency with the adjacent curves. That was one thing that we had noted was, the driver's ability and expectation about how they experience those curves. They find it particularly challenging, especially if they're in a series. So thinking about those holistically and from the motorcyclist perspective, providing as much advanced warning and delineation as possible. So through large driveway entrances or intersections, providing additional pavement markings to help to guide the drivers through those sections. Improving roadside conditions and removing fixed objects along the roadway. So thinking about the grade, providing crash buffers or removing fixed objects. And I had also mentioned before some of these other ones that were implemented, such as corridor access management, really had a big impact in urban areas. And lastly, I would note conducting motorcycle RSAs, as that is a great tool to help to investigate site-specific needs. So with that, thank you so much for your time, and I hope that you consider using this tool yourselves in the future.
Thank you so much. And at this time, we are going to take some questions for Alyssa. So if you have questions, please put those in our question pod. And while we're waiting to see if any come in, we are going to do a poll question for you all. So Dana, if you could please pull up our poll question. Our first poll for y'all is conducting motorcycle road safety audits can, and please select one of these. Demonstrate a commitment to motorcyclist safety, allow collaboration with motorcycle safety clubs, lead to implementation of motorcycle safety measures, all of the above or none of the above. And we'll give everyone just a few seconds here to fill this out. Okay, Dana, if you could please show us the results. And Alyssa, I'm going to ask you to go ahead and address the question, please.
Yeah, great. Thank you. It looks like almost all of you got it correct. It is all of the above. So as I mentioned before, that these road safety audits really did help to demonstrate that commitment to motorcyclist safety, provided opportunities for collaboration with motorcyclist safety clubs, and really helped to facilitate the implementation of motorcycle-specific safety measures. So if you answered all of the above, that is the correct answer.
Thank you. And we did get a few comments and one question for you. So a few of the comments that have been coming in through the question pod are agreeing with a lot of the things that you said, including that there was a study done, MSF 100, that does suggest that motorcyclists don't report all crashes, as you mentioned. And someone else did say that a majority of motorcyclists they've found don't seek additional training beyond whatever is required by the licensing organization. So they were agreeing with all of those things. But one question that did come in for you is that in the safety countermeasures you just went over, you mentioned implementing corridor access management. And so they are interested in getting a little bit more information and possibly the definition for corridor access management from you.
Yeah, that's a great question. So on one of the slides there, we're just trying to picture more of a suburban multi-lane roadway with many different driveway access points, multiple lanes going through it. So there's a lot of different things that are taking the driver's attention of, I would say more traditional motorized vehicles. And so oftentimes the motorcyclist itself, they can be overlooked in this process. So if we can kind of streamline some of what is going on in these types of corridors where there are multiple lanes, many different access points, so just to help to control that a bit better, it reduces the potential numbers of conflict points for all drivers. But there is a particular benefit to more vulnerable road users, such as motorcyclists, and I would include bicyclists and pedestrians in that as well, because they're oftentimes the ones that are overlooked by drivers of traditional motor vehicles. So that can help to improve safety for everyone, and including these vulnerable road users.
And Alyssa, another question that we received for you, is there a standardized method for rating corners for recommended speed? They mentioned that oftentimes the speed recommended is not accurate, but then you hit one where you really mean like 15 miles per hour.
Yeah, that's a great question as well. And I believe that all of the, when we look through the MUTCD and the curves and what's needed there, that's oftentimes the ball bank tests are run based on using traditional vehicles to be able to do it, a truck or a passenger car. And so it might not accurately reflect the experiences of motorcyclists. And so what some of these other agencies did was to be a bit more conservative on their routes in terms of, additional signing or enhanced signing, especially advanced warning signage and the approach to the curve, and then providing delineation through the curve. So I don't believe that I know of, and maybe some of the other panelists might know of, standards related to signage for motorcyclists and the speeds appropriate for them at curves. But that was the approach taken by many of the agencies that we conducted these road safety audits with in particular.
Another question that we received for you, you mentioned that paving the inside of the shoulder of a curve was important. So someone would like to know why you felt like that is more important than the outside of a curve. Inexperienced riders have trouble turning sharp enough, thus leaving the road on the outside.
Yeah, that's a great question. And that was something that was brought up based on some specific experiences on crash types for these particular road safety audits. And so given some of the crash data there, and I have to wonder if part of it is because of the way that they were taking those roadways. For example, the roadways that we had noted in North Carolina were really a destination for visitation for people riding motorcycles. So they were experiencing a lot of drivers that were from outside the area on motorcycles who were driving incredibly fast and trying to sort of take them, almost drive it more like they're racing. And so I think in terms of some of those experiences were related to that particular site. I would not say that these are, necessarily transferable to the motorcyclist experience across the board, but more indicative of what we saw in terms of the crashes at these locations.
And I have one final question for you, and then we'll move on to our next speakers. And if we have time, we'll get back to some of these other ones that have come in the question and answer pod. But this one is, what about rural roads that use gravel and don't have shoulders? What are some low-cost safety measures for those types of areas?
Yeah, and that's a great question too. And I think gravel provides its own challenges to all roadway users, but in particular to motorcyclists. I think some of the best things that can possibly be done there are thinking about the maintenance that's done on the gravel roads. So how much rutting is occurring, or kind of that washboard effect to it. Maintaining as smooth as possible type of surface on those gravel roadways. I think, getting back to the types of delineation and the speed setting on those roadways as well. I think what you can do to provide as much warning as possible for riders that are entering an unpaved road from a paved one, and then just trying to think of the experience in order to help them to maintain stability on their bikes as much as possible. And back to some of the enhancements to enhance the conspicuity of curves and the edge of the roadway as much as possible, since you're not going to be able to put down edgeline pavement markings, thinking about maybe post-mounted delineators or other features to enhance delineation.
Thank you so much, Alyssa, for all of your expertise that you've shared on road safety audits. And we do have a few questions that, if we have time at the end, we'll bring those back up for you. But now we're going to move along to Karen Asplin. Karen is a registered professional engineer in 6 states. She has a Bachelor of Science in Civil Engineering from the University of Virginia and a Master of Science in Civil Engineering from Texas A&M University. She is a technical leader in transportation for Olson in their Colorado Springs office. Her consulting involves projects related to traffic studies and design and active transportation. She recently worked on an FHWA project as a subcontractor to the Texas Transportation Institute related to infrastructure and motorcycle safety, and we'll hear some of the results right now from that study. So, Karen?
Thank you. All right, let's get started. So I'm wondering, have you heard of a group called the MAC? Well, the MAC is the Motorcycle Advisory Committee, and it was reestablished by the FAST Act in 2015. The MAC is a group that's responsible for providing advice and recommendations concerning infrastructure issues related to motorcyclist safety. And that includes barrier design, road design, construction and maintenance practices, and architecture and implementation of ITS. So the MAC was comprised of 9 people, and it finished its recommendations in March of 2020. And several of these recommendations are going to be addressed throughout the webinar today. But the MAC kind of summed everything up in its document by this statement: "It is clear from our work that motorcyclists are too often an afterthought when designing, constructing, and maintaining the nation's roadways. So Federal Highways addressed the MAC's recommendations by contracting out a project. And the purpose of the project was to collect and analyze the current state of practice and state of research, and to identify implementation needs, research needs, and corresponding projects to address the MAC recommendations. And while the MAC report also listed recommendations involving things such as vehicle miles traveled data for motorcycles and the appointment of state officials responsible for motorcycle safety, the basic charge of this project was to focus on the items that are shown in this list here. So Alyssa kind of stole my thunder earlier with some of the safety stats, but I'll see how well you remember. So in 2020, motorcycles accounted for less than 1% of the US vehicle miles traveled. But what percentage of US highway fatalities were motorcyclists? And if you recall correctly, that number is 14%. And with the continued efforts by US DOT, all other motor vehicle fatalities, including people in passenger cars, people in pickups and SUVs, those have all decreased during the past 2 decades. But unfortunately, motorcyclist fatalities have increased significantly during that same time period. And most recently, things have only gotten worse. These graphs use that FARS data that Alyssa talked about through the year 2019. But look at what happened in 2020. While the total US vehicle fatalities decreased from a high near 50,000 back in the 1980s to under 40,000 in 2020, motorcycle fatalities decreased to a low around the year 1996. And now they're back to the levels where they were in the 1980s. And since I first created this slide, NHTSA has published early estimates of traffic fatalities for the year 2021. And the situation has just gotten even worse. The total traffic fatalities increased more than 10% over 2020. This was the largest annual increase since the FARS was even established. Motorcycle fatalities were literally off this chart at over 6,100. And if zero fatality plans are to be achieved, safety issues involving motorcyclists will have to be both recognized and addressed. So for the most part, states have been using strategies to improve motorcycle safety that try to affect motorcyclist or driver behavior. And the main strategies that have been used by states to improve safety include things like law enforcement programs, information and education campaigns, personal protective equipment, motorcycle rider licensing, and motorcycle rider education and training. However, NHTSA's uniform guidelines for state highway safety programs states that traffic engineering is a critical element in providing for the safe movement of motorcyclists, and that this engineering component should improve the safety of motorcyclists through design, construction, operations, and maintenance. However, what we found in our research is that it appears there are a few states that are addressing engineering solutions to motorcycle safety. So obviously, motorcycles are very different from other vehicles on the road. First, and Alyssa had addressed this earlier, they lack that external structure that protects them, or that could protect them when a crash occurs. And what this means is that also in a crash, a motorcycle is very likely to be separated from the vehicle, as well as directly exposed to roadside structures like barriers, things that are actually expected to protect them, to protect people on the road. And next, motorcycles are very much smaller than other vehicles. A motorcycle could be found in the center, in the left, or in the right of a lane, and since the typical roadway lane is 10 to 12 feet wide, and a typical motorcycle is only 1 to 2 feet wide, it can make them difficult to see. On the other hand, a passenger car will almost always be near the center of a lane, since a car is typically wider than 6 feet. And not only are motorcycles narrower, they're shorter in length too, and they can accelerate faster than other motor vehicles. And these two characteristics make the default values used for calculations for passing sight distance, as one example, inappropriate for motorcycles. Finally, only having 2 tires in line makes the stability of each tire very important. So they're very vulnerable to conditions and frictional characteristics of the roadway that might not impact a typical passenger vehicle. Potholes, milled pavement, and edge drop-offs can introduce more immediate and significant negative impacts on motorcycles as compared to people in cars. To sum it up, the researcher Willett said, passenger vehicles simply do not roll over on their side as soon as some instability develops, but motorcycles often do. Let's look at the history of motorcycle safety research. Probably the most well-known study of motorcycle safety is what's known as the Hertz Study, and it was published in 1981. It involved documenting and reconstructing 900 motorcycle-involved crashes. The Hertz Study looked at the effectiveness of motorcyclist safety equipment in use at the time and identified potential countermeasures for motorcycle safety. The study found that in multi-vehicle crashes, the driver of the other vehicle often did not see the motorcyclist. And accordingly, the main recommendations for countermeasures focused on training and the need for more conspicuity of the motorcyclist. However, the research team did recognize the effect of environmental factors on motorcycle safety, noting that while pavement irregularities may not be the main cause of crashes, they're often contributory, as the motorcyclist must balance their awareness of the pavement with the roadway in general, as well as other nearby vehicles. In 1998, the European MAID study, and MAID is short for Motorcycle Accident In-Depth Study, involved an analysis of 921 crashes. The MAID study also addressed exposure by interviewing motorcyclists in similar situations who were not actually involved in a crash. In 2008, there was volume 22 of NCHRP 500, produced as part of the AASHTO Strategic Highway Safety Plan implementation effort. The report was called A Guide for Addressing Collisions Involving Motorcycles, and it specifically focused on motorcycle safety. It included an implementation objective specifically related to design, construction, and maintenance of roadway facilities. And then Federal Highways published a final report on their Motorcycle Crash Causation Study, or MCCS, in 2019. And the major findings from that study were that single vehicle crashes occurred more frequently on curves than on straight sections of road, and that fatal crashes were associated with tighter curves. So we know that motorcycles are different from other vehicles on the road. That being said, how do our engineering design manuals address the difference of motorcycles? So for the non-designers in the audience, AASHTO, or the American Association of State Highway and Transportation Officials, publishes a manual called A Policy on Geometric Design of Highways and Streets, which is familiarly called the Green Book. And this is the guidebook used by American engineers for highway design. So what do you think, how many times do you think the word motorcycle is found in the 2018 edition of the Green Book? Well, would you believe it is only 4? And one of those is in the context of motorcycle noise pollution, which I found very interesting. The Green Book only mentions it 4 times. However, this is just a question for you to ask yourself. How often have you considered how your design would affect motorcycle safety? I've been designing roadways for over 30 years now, and I have to admit that before I started this research project, it was not something that was foremost at my mind. One of the MAC recommendations has to do with considering the motorcycle as a design vehicle. The AASHTO Green Book currently does not have a motorcycle design vehicle. Rather, it says that motorcycles are specifically included within the broad category of automobiles. The MAC pointed out the problem that the unique characteristics and behavior of motorcycles are not properly considered in road design manuals and guidance, and recommended that research into a motorcycle design vehicle should be conducted. And as an example, this is a motorcycle design vehicle that is found in some design manuals in Europe. So the next edition of the AASHTO Green Book is currently underway, and it's too early to be seen whether it will include a motorcycle design vehicle. However, we do know that there are members of the former MAC on that committee to design the new Green Book. The geometric characteristics associated with motorcycle crashes that are commonly cited in the literature include horizontal curves, intersections, cross-sectional characteristics, and sight distance limitations. First, we're going to talk about horizontal curves. They can be problematic as they reduce available sight distance and can negatively impact vehicle handling, especially the handling of motorcycles. This figure shown here is a crash decision tree based on motorcycle crashes in the state of Rhode Island, and it uses risk factors associated with daily traffic volume, shoulder width, and horizontal curve radius to prioritize horizontal curves for safety improvement projects, specifically for motorcycles. To give you an idea of how much of a concern horizontal curves are for motorcyclists, one Florida study determined that even though curved roads account for only 6% of the number of miles in Florida, 57% of single motorcycle fatal crashes occurred at locations with a horizontal curve. The same study determined that the length of the radius of the horizontal curve is the most significant feature influencing the frequency of crashes. Horizontal curves with a radius of less than 1,500 feet are associated with an 8% or more increase in motorcycle crashes, whereas horizontal curves with a radius of more than 4,000 feet are basically considered flat and are not associated with an increase in crashes. Intersections are the bigger concerns for crashes involving both a motorcycle and another vehicle. The MCCS found that nearly 80% of multiple vehicle crashes involving motorcycles occurred at intersections, and many of these involved a vehicle turning left in front of a through-moving motorcycle. We've already pointed out that motorcycles are smaller and may be located in any part of the lane, which could make them easy for a turning driver to miss. As well as not seeing a motorcycle at all, drivers may see the approaching motorcycle but underestimate its speed. One driver simulator study found that drivers were more likely to make a left turn in front of a motorcycle than they were to make a left turn in front of a passenger car that was viewed at the same distance. From the perspective of the motorcyclist, a study using eye tracking technology observed that motorcycle riders glance more often at the road surface than did other drivers at an intersection. So motorcyclists entering an intersection has to perform multiple vehicle guidance tasks while also continuing to scan for traffic. This is due to that fact that motorcyclists are so concerned with the pavement surface when making a hard turn. We'll address ITS safety solutions later in this webinar, but motorcycle crashes at intersections could be an excellent application for vehicle-to-vehicle technology. I mentioned earlier that through our research, we did learn of a few states with noteworthy motorcycle-specific engineering practices, and one of them is the Ohio DOT. At a signalized intersection, dilemma zone detectors identify vehicles approaching an intersection and can extend the green light to allow a vehicle to safely pass through on green. The problem is that due to their smaller size, motorcycles are often not detected in the dilemma zone. And if that happens, the signal could change to yellow at a point where it may be necessary for the motorcyclist to choose between braking hard or entering the intersection at the end of the yellow, which could increase the risk of a crash. The Ohio DOT has in its standard construction specs a requirement that all stop line detection zones shall reliably detect motorcycles and bicycles, and that all dilemma zone detectors shall reliably detect motorcycles. They're using a type of loop detector that is asymmetrical and positioned diagonal to traffic, as well as a larger pole-mounted radar detector, both of which identify motorcycles better than other detectors do. Let's talk about how cross-section characteristics may affect motorcycle safety. While paved shoulders are considered safety features for all motor vehicles, they play a particularly important part in motorcycle safety, as paved shoulders can be used by motorcyclists as a location to take evasive action. The Roadside Design Guide is another AASHTO manual, and it's used by road designers to determine the design of the clear zone. The clear zone is an unobstructed, relatively flat area beyond the edge of the traveled way that allows a driver to stop safely or regain control of a vehicle that leaves the traveled way. And AASHTO's Roadside Design Guide is completely silent on motorcycles. However, what we learned through our research is that clear zones designed for cars may be inadequate for motorcycles because of a motorcyclist's riding position within that lane. Additionally, clear zones designed for cars may be inadequate for motorcycles because they would need to consider not the motorcycle, but the motorcyclist who has likely been thrown from the bike. And finally, treatments like barriers and rumble strips installed for motor vehicle safety may function very differently for motorcycles. And later on in the webinar, there'll be a much more robust discussion of barriers. Road designers often perform sight distance calculations as part of their work using guidance from the Green Book. Sight distance is the length of road visible ahead to a driver. And the Green Book is used to design roadway facilities with sight distance that is sufficient for a driver to see, react, and stop or maneuver to avoid a collision. As I mentioned earlier, however, the design calculations in the Green Book are based on the characteristics of passenger cars and passenger car drivers. Calculations in the Green Book do not consider the unique characteristics of a motorcycle or motorcyclist in designing facilities that provide adequate sight distance. There are different types of sight distance calculations based on the type of maneuver a driver is making. This top figure shows a diagram of an intersection sight distance. In this situation, the factor of motorcycle size becomes apparent. When a motorcycle is the opposing vehicle in an intersection sight distance calculation, in other words, the vehicle on the left or right in this diagram, their small size compared to a passenger car makes them easily obscured by vegetation, road signs, and other obstructions. There's also a requirement for passing sight distance shown in the bottom diagram. Passing and no passing zones on two-lane highways are marked according to this calculation. But a motorcyclist's faster acceleration capability makes the passing sight distance calculations for no passing zones way too conservative for motorcyclists. And what may happen is that motorcyclists will disregard signed and marked no passing zones and attempt to pass in no passing zones that may be inadequate. So the next topic is only loosely related to road design, but was part of the project summary report. And I felt it was important to bring up in this webinar as it seemed to be the motorcycle behavior that was brought up most often when I mentioned to other people that I was part of a research study on the safety of motorcycles. And it's the topic of lane splitting and filtering. Currently, California is the only state where both lane splitting and lane filtering are legal. Lane filtering only is currently legal in the states of Utah, Montana, and will be later on in this year in Arizona, as it just passed the vote there in March. And I was surprised to find research that showed that lane splitting had any proven benefits, but there is limited research showing that it may keep motorcycle riders safer under certain speed conditions because it allows them to move between vehicles and traffic, giving them an escape route when there's congestion. And particularly to allow them to avoid being in a rear-end crash. Now, the purported benefits of lane filtering are that it allows motorcyclists to avoid being hit from behind when stopped in a queue. It reduces congestion, fuel consumption, and emissions, and it helps prevent some motorcycles from overheating. Finally, it allows motorcyclists to save time because motorcyclists at the front of a queue can accelerate quicker than cars and leave the platoon from behind them. And you can see at the bottom of the slide the different definitions between lane splitting and lane filtering. So highway design manuals show a lack of attention paid to motorcyclists, and consequently motorcyclists are not on the mind of the highway engineer. We've already mentioned that the Green Book mentions motorcycles just 4 times and the Roadside Design Guide not at all. Another manual that I'll mention is the Manual on Uniform Traffic Control Devices. The MAC recommendations are that federal highways must work with AASHTO to review design manuals and guides for topics that should be expanded to include motorcycle-specific language and guidance, and that wherever possible, FHWA should work to disseminate relevant guidance to states to address these recommendations. Now back to the METCD. The current METCD contains just 2 signs that are specific to motorcycles. Both are supplemental plaques. One is used to supplement warning signs in either a permanent or a construction condition, and the signs are intended to give motorcyclists advance notice of surface conditions that might affect motorcyclists' ability to maintain control of their motorcycle. The second sign is a regulatory plaque that is used to supplement preferential lane signs, such as signs for HOV lanes. And the proposed amendments to the METCD do not include any new signs specific to motorcycles. It should be noted that the National Committee on Uniform Traffic Control Devices, a private organization that develops recommendations to federal highways for consideration when updating the METCD, has 21 sponsoring organizations. And while 2 of those groups represent bicyclists and 2 of those groups represent railroads, there are no organizations that represent motorcyclists on that committee. So that concludes my part of the webinar, and now I'll see if there are any questions that I can answer.
Perfect. Thank you so much, Karen. And if you do have any questions, please make sure to put those in the chat pod. We're going to answer just 1 or 2 here right now. And we are going to skip our poll question to ensure that we can hear Georgine speak as well. But the very first question that we had come in, it's kind of a 2-part question from 2 different people, but it was about the statistics that both you and Alyssa described for motorcycles. And so the first one would like to know if those statistics might include off-road use. And the second one is wondering if there's any correlation of the numbers being much higher due to COVID when people may have started riding motorcycles because they were cheaper in regards to gas and providing more freedom.
I can try to address those. First, I do not believe that the statistics include off-road users. I'm fairly certain of that. Regarding the second question about the higher use of motorcyclists because of COVID, and also included with that, I will say just the higher price of gas. I would have thought the same, that more people are riding motorcycles. However, what I've heard is at least it's apparently very difficult to acquire at least a new motorcycle that is very gas efficient right now, because there is apparently they're all stuck in that supply chain mess. However, that doesn't mean that people who do already own motorcycles aren't using them more. And that gets back to that vehicle miles traveled question. I think Alyssa mentioned it's a statistic that's difficult to acquire for motorcycles, and so I'm not sure if that will be able to be determined or not.
And Alyssa, did you have any follow-up to either of those questions by any chance?
Yeah, I would just add in that the crash statistics come from FARS, and so and are reported by NHTSA, and so you can find those in the NHTSA crash publications. And the FARS data is limited to crashes that are on the roadway, so it does not include off-roadway riding.
Perfect. Thank you so much. So at this point in time, we're going to move forward to our next speaker. Thank you very much, Karen. And again, if we have time at the end, we'll go through a few more of these questions that we do have, which could be addressed by any of the 3 of you. But Georgine is a registered professional engineer in Georgia and has a Bachelor of Science in Civil Engineering from the University of Illinois, Champaign-Urbana, and a Master of Science in Civil Engineering and a PhD from the Georgia Institute of Technology. She retired from the Georgia Department of Transportation in 2014, where she had spent her career involved in all aspects of transportation and transportation research. She is now the principal engineer or owner of GGFGA Engineering. Her consulting involves projects related to transportation research, especially materials and pavement design. She recently worked on an FHWA project as a subcontractor to the Texas Transportation Institute related to infrastructure and motorcycle safety. And so she'll be providing some additional information from that project, following up on what we just heard from Karen about. So Georgie?
Thank you, Jamie. Great, I'm going to talk about the special needs of motorcycles as related to roadside barriers, pavement friction, and maintenance and construction. And then finally, I'll cover some of the challenges and potential benefits of ITS, or Intelligent Transportation Systems, to motorcycle safety. Now, these pictures are from a car impacting a guardrail in a MASH test. You can see how the car impacts the guardrail at an angle and then is redirected along the guardrail. And you may know that roadside safety barriers are designed to contain and redirect vehicles, like shown in the pictures here from the MASH testing. In most cases, the barriers only serve their intended purpose if they maintain the vehicle and, of course, the occupants on the impact side of the barrier. You may also know that there is MASH testing criteria for cars and trucks, but not for motorcycles. Now, this is a graphic depiction of what can and often does happen when a motorcyclist impacts a roadside barrier. The motorcycle first impacts the barrier, then they're ejected from the motorcycle, and then they can be thrown over the barrier, potentially right into the object the barrier was designed to protect them from. Now, this is obviously a challenge for a motorcycle impact at any kind of speed, as the rider can be separated and ejected from a motorcycle much easier than a passenger can be ejected from a vehicle. Now, beyond being ejected over the barrier, an impact into a barrier itself can also do damage to a rider. For guardrails, like these shown here, the post itself can become that object struck. Even with a helmet on, a direct impact, as shown in this bottom right, can be deadly for a motorcyclist. From a study that we found of 951 motorcycle barrier crashes in North Carolina, Texas, and New Jersey, the researchers there found that 57% of the motorcycle barrier crashes were related to guardrails, as compared to concrete barriers. And that makes sense because guardrails are typically more prevalent on the roadway. But this study also looked at which type of barrier carries a higher risk for motorcyclists. And they found that crashes involving a guardrail were 1.4 times as likely to result in severe injury, where the motorcyclist was killed or incapacitated, as compared to rigid concrete barrier. Now, as guardrail is more prevalent in rural roads than concrete barrier, this is probably important for y'all. And what the impact of that is while motorcycles are only about 3% of the vehicle population, they were 40% of guardrail-related fatalities from this study in 2017. One of the federal highway reviewers that was part of this project actually questioned that, but that is true. And there will be a project report coming out very soon that's going to give you some more details and some more specific crash-related data on barriers and motorcycles. Now, barriers are designed to cause less harm to a vehicle than the object it's shielding. But due to the high number of fatal impacts with barriers that they identified in this NCHRP report, the researchers noted that there is additional research needed to confirm that current barriers are less forgiving for motorcyclists than just striking the object itself. Now, some US states are looking to address this issue by adding motorcycle protection systems. You can see here, this adds another rail down below the top rail. So if a motorcyclist hits it, they'll run along the rail instead of hitting the post. California, North Carolina, and Utah have all installed these MPS. Utah has particularly seen good results, like shown here. They're also one of the states that are part of a pool fund project related to motorcyclist safety. This pool fund research project, shown here, it's led by Texas DOT, and it's ongoing, and it's addressing barriers and motorcycles, and they're developing and testing retrofits for concrete barriers, like shown down here on the bottom right, which would prevent the motorcyclist from being ejected over the barrier, and then also for different retrofit designs for guardrails. So these are different types of designs for the guardrails. Next, I'm going to cover pavement and friction as related to motorcycles. both of our speakers before talked about how friction is important for motorcycles. And we're going to talk about the materials that go on top of pavement. Now, Karen had noted that US design guidelines do not really address motorcycles. We did find the Institute of Highway Engineers of the United Kingdom, they have guidelines for motorcycling. And the guidelines recognize the need for consistency in pavement friction for motorcycles. But we also found that current friction testing of pavements in the United States is not a continuous measurement. Testing is primarily done with a locked wheel tester, like shown here on the left. It has a separate test tire in the trailer on the back that is set on the pavement, and then the water is sprayed in front of the tire, and a brake is applied just to that tire. The rest of the vehicle is moving, and the test tires skid on the pavement very hard for 50 feet, and that's how it measures friction. Now the result is we only get average friction readings over that 50 feet, and we only test occasionally, every mile or at best every 1/10 of a mile. So due to the speed and the condition of the test, it's not performed in curves or approaches to intersections typically. Now, two things that motorcycles need are predictable or continuous friction and friction in curves and intersections. So the way we test in the US currently cannot measure either of these. Now on the right here, Europe has been using what's called a continuous friction measurement equipment, or CFME, since the 1920s. One type of a CFME or SCRIM, sideways force coefficient routine investigation machine, it actually started out as a motorcycle with a sidecar, with a small tire on the side. And that was back in the 20s. But the current SCRIM uses a similar method, a similar smaller tire, and it's angled slightly, and it's run just along the top of a continuously wetted pavement. So this type of equipment can provide continuous, down to like every 4 inches, friction measurements, and can test on curves and intersection approaches. Now this figure here shows CFME results. And where red is lower friction and green is higher. And this is showing going through a curve. The results show that the friction decreased through the curve and was lowest near the center of the curve. Now, I mentioned that the lock wheel tester really can't test through a curve like the CFME. Now, AASHTO also has a provisional test standard for a CFME, so potentially more of this type of testing can be done in the US in the future. Now, also the update to the AASHTO Guide to Pavement Friction that will be published next month in September now will include the importance of friction for motorcycles. Previously, it had only addressed the special needs of trucks. Now, HFST may be beneficial for motorcycles. Now, we didn't find any research specifically looking at this, but we did identify that Rhode Island DOT had done a section of roadway with HFST, and they noticed noticeable safety improvements for motorcycles after installation. There was an average of a motorcycle crash a year in the 5 years before the HFST was installed. And 7 years after, they had no motorcycle crashes. Now, even if the pavement is designed, constructed, and maintained in a manner conducive to good frictional properties, it can actually be for naught if the pavement markings placed on top of the pavement have vastly different friction characteristics. Now, in general, the US has really focused on visibility and not friction of the pavement markings. We did find some work from Europe where they have been looking at friction on pavement markings. And the MUTCD does recognize the issue of loss of traction. This is in the MUTCD, but it really doesn't include any recommendations on how to address it. We did find some states that have standard practices that include leaving gaps in the pavement markings. Just like the detail shown here from, this one's based on Oregon DOT guidelines. So a few states are also addressing the frictional properties of the pavement markings themselves. Minnesota DOT is increasingly utilizing roundabouts as a proven safety countermeasure, since roundabouts have been shown to provide about an 80% reduction in severe crashes compared to typical intersections. And that's for all vehicles. Now, due to the motorcycles community concerns with the pavement markings used in roundabouts, I don't know if you've ever stepped on one of these when they're a little bit wet. They can be slick. So the motorcycle community was concerned with the pavement markings that they were using. So Minnesota DOT is testing a new method using enhanced skid resistance markings in the roundabouts. And they also had already been using the motorcycle friendly crosswalks. Minnesota DOT also has a first of its kind, haven't seen anything like it in over 40 years, research project underway at the University of Minnesota that's investigating differential friction effects caused by pavement markings. Florida DOT is another state that is looking at friction on their pavement markings. They're adding shields to some high-profile roadways to improve guidance and potentially reduce wrong-way crashes. The DOT recently added shield markings with additional frictional characteristics on Interstate 95 at Interstate 4, and those two meet near Daytona Beach. And there's an annual bike week at Daytona Beach that attracts a lot of motorcyclists. Now, Florida DOT already had requirements in their specifications for pavement markings with frictional properties for certain locations. And they're now expanding those frictional requirements for pavement markings in their state specifications. The next topic I wanted to cover is maintenance and construction. Now, motorcyclists have a number of concerns related to this area, as you will see in a second. I will share with you some of the efforts that we found that attempt to address these concerns. So here are the construction and maintenance recommendation areas from the MAC report. Karen previously talked about the MAC, and she actually mentioned number 11, signal detection systems for motorcycles. 9 of the other 10 MAC recommendations, the ones highlighted here, involve road surface condition. Now, I already talked about pavement marking friction, number 10. Next, I'll talk about a few of these other concerns related to roadway condition. Now, of course, even car drivers are annoyed by potholes, uneven surfaces, loose material on the road, and you may be even jarred, or a rock may strike your windshield and crack it if you're in a car. But those same conditions could cause a motorcyclist to lose control or knock them off the motorcycle. Now, state DOTs normally use contractors to perform construction work. And now many also use contractors for maintenance. States use their construction specifications to communicate with contractors. So we looked at states' construction specifications online to see if they addressed motorcycles. Well, only 10 states were found to even mention motorcycle or motorcyclists, showing here 2 of the exceptions. So 80% of the states were found to not mention the word motorcycle or motorcyclist in their standard specifications. Now, you may think that they were just totally silent on vehicle types in those documents. But interestingly, over half of those that did not mention motorcycle did mention bicycles, and numerous times. 2 of the 10, Virginia and New York, both identified pavement condition considerations specifically for motorcyclists, as shown here. Now, the motorcycle plaque, shown here on the bottom right, as Karen noted earlier, it's currently a non-mandatory sign, but some states went a little bit farther. New Hampshire and Maine, they both require the motorcycle plaque to be used by their contractors in certain conditions, like shown here, milled surfaces or running over rumble strips. Now, advance notice for construction sites, we found Montana DOT has a standard policy that requires that in the pre-construction phase of every project, that they look at the project's effect on motorcycles. Projects that require traffic running on temporary gravel roads or milled surfaces can present potentially adverse conditions for motorcycles. So these projects include advisory signs at each end, like the one shown on the left. The signs are specific to a particular project route, and they're strategically located. Right over here, beyond this sign, is a rest area. And so a motorcyclist can go and stop, and they can go and check the motorcycle website, the Montana DOT website, or look at a map and look for alternative routes. Now, in a survey we had found that was done in Ohio, over 70% of the motorcyclists surveyed would prefer detour around a work zone. And almost 30% of them noted they would even go over 20 miles to avoid a work zone. So obviously, motorcyclists have concerns with work zones. Now that's why training like we found here, specifically for construction and maintenance personnel in regards to motorcycle safety in work zones, is so valuable. ARTBA, the American Road and Transportation Builders Association, has a 1-hour work zone training for motorcycles and bicycles, which has a quiz at the end, and you can even get a certificate of completion. Now that's if you pass the quiz, like I did. Now this training and the website itself were developed through the Federal Highway Grant. This site also has a link to a document titled Guidelines on Motorcycle and Bicycle Work Zone Safety. The document provides additional recommendations to provide a safe work zone for both motorcycles and bicycles. Now, finally, I'm just going to touch on intelligent transportation systems and motorcycles, just briefly describe the technologies, and share with you some of the challenges and benefits. Now, connected vehicles and automated vehicle technology, they either assist the driver or transfer the driving task to the technology. And connected vehicles, they can involve communication between vehicles and between vehicles and the roadside infrastructure. ARAS, or Advanced Rider Assistance Systems, they're technologies capable of helping a motorcyclist, this is specifically for motorcycles, with riding tasks through a variety of applications and methods. And they're somewhat similar to what you would see for cars, but they call it ADAS, Advanced Driver Assistance Systems. Now, anti-lock brake systems, they've shown great promise, and we've found some good research on that, on how they are improving motorcycle safety. Motorcycles can also have cruise control, stability control, and different types of warning systems. And this here is not an exhaustive list. There was at least 8 others in use that were identified in the final report. And at the end, I'll tell you where to find the reports. Now, a major challenge is that motorcycles are not being considered in ITS or connected vehicles or automated vehicles planning documents now. But, can you envision a driverless motorcycle? No, but motorcycles do need to be considered, just like bicycles and pedestrians need to be considered, but maybe even more so. Motorcycles have special challenges as they're part of the current motorized traffic stream. So even on routes where ped and bikes are not allowed, like interstates, motorcycles are there. So there's some specific concerns of how we're going to do this with motorcycles, how to put the sensors, how to notify the motorcyclists, will that technology overwhelm the riders? But there are also some potential benefits that I think outweigh those challenges. Some of the benefits of connectivity and automation, I think Karen kind of alluded to it, includes helping the motorcyclist to be seen better by other vehicles and to see other vehicles and infrastructure in advance. So this increased conspicuity and shortened reaction time required of a rider could definitely be a safety improvement. There could be some benefits for novice riders, getting them to practice and improve their riding. And definitely the advanced warning that could be provided in situations like construction ahead, or alerting the riders to detours, similar to what Montana does with their motorcycle advisory signs, but in real time. Now, this was a Federal Highway sponsored research, so we have to give you those Federal Highway disclaimers. And there are 4 reports that you could look at. one specifically on barrier design, one that covers the geometry, the pavements, and maintenance practices. The noteworthy practices, all 9 noteworthy practices are in this document. And then you have a separate document just on ITS. So these are all now available on the website. And got to the questions.
Thank you so much, Georgine. And we've had a lot of questions coming in, and some of them are very similar. So I'm going to ask these of you, but if they're ones that maybe aren't from your section or you don't feel comfortable addressing, if you just want to see if one of the other speakers are able to answer them, that would be great as well. But one of the first ones that a lot of people are asking is about the barriers that you were talking about and the crashes that occur with motorcyclists and the impact of those barriers. You talked a lot about guardrails and concrete, but we're getting a lot of questions in here about if you have any information on cable median barriers.
Yeah, for time I had kind of specifically taken cable barriers out. They found that the cable barriers were similar to guardrails. Motorcyclists seem to have a big problem with cable barriers. They even, in the report, it mentions what they call them, cheese graters. But there hasn't been any research that has found that they are worse than guardrails. And the posts are actually farther apart on cable rail than on guardrail. So, there wasn't enough cable rail in that NCHRP project to be able to really say, anything about it. So there hasn't been any research showing that it's worse.
And has anyone tried a similar approach as with the guardrail with the extra yellow rail that you talked about there? Do you know of any studies of people trying additional things with cable barriers?
In the report, this was actually something out of Europe that they had a piece of plastic that you could put on the cable rails. I don't know if it actually was used, but this was something that we had found was proposed in Europe.
Perfect, thank you. So for anyone looking for more information on that, again, the links are available in the PDF that's posted for download right now, and you can look up that report that Georgine is mentioning to get additional information on that study. Another question for you, Georgine. Again, a couple came in about this same thing, but when we're talking about pavement, there's a lot of crack sealing that goes on, or tar snakes as they're more affectionately recalled or referred to, and those are dangerous for motorcyclists. So people are wondering if there are standards or training being provided to maintenance crews on those, or anything that you would suggest to make that a little bit safer.
And I am almost positive that is addressed in the guidelines that I mentioned, the ARPA training, and in the guidelines that they do talk about that. But it is funny, it's in the report that I found kind of like a best practices document, and it talks about the benefits of over sealing for the engineering part of it, but they don't address the motorcycles or don't address the friction part of it. So I would encourage them to look at the ARPA training for that.
Perfect, thank you. And then the last question for you all that came in again several different times is still about the speed of motorcyclists. And one of the questions in here is referring to the list of countermeasures that was, I believe it came out of Alyssa's presentation about strategies, and the questionnaire is saying that a lot of those strategies were to increase comfort and acceptable motor vehicle speeds on a roadway, but is there any evidence to support that traffic calming or other environmental indicators could be used to prompt motorcyclists to slow down as opposed to keeping them at full speed?
Yeah, this is Georgie. We didn't find it in our study, but at least you may.
Yeah, this is Alyssa, and I would just say that, I think there's some thought that enhancing roadway delineation could potentially increase driver speed, and I think that might be partially what they're alluding to. I think there's some school of thought around that, but then there's also sort of another sort of sentiment that it could possibly be that providing that enhanced delineation allows drivers to, and motorcyclists in particular, to adequately prepare for the conditions that they are going to be encountering. So that may cause them to lower their speeds because they can see that they have a series of upcoming curves that they're going to have to navigate. And I don't believe that there is really research that has indicated that enhanced delineation has done either increased or decreased speeds. Those are just sort of anecdotal based on feedback and thinking through it from kind of a human factors perspective. But I would say just in general, certainly any measures to decrease speeds certainly would allow motorcyclists a better ability to see and react to potential conflicts on the roadway, or to also reduce the impact if there was a crash, so that hopefully it's more survivable.
So at this time, I do want to thank all of our speakers for answering the questions that we have. I am going to go through just a few additional slides for everyone here. So I do want to point you again to those resources that were discussed throughout today's webinar. All of these, again, are available for download within the PDF that we have. I'm also going to attempt to post these in the chat pod. I believe that I should be able to do so. So I'm going to try and do that. I'm going to post the FHWA one where you can find the 3 bottom reports are all listed on that same motorcycle webpage. And then I will post the motorcycle road safety audit here in a second for all of you as well. But again, you can download this PDF to have all of these resources. I do want to mention a couple of upcoming things. September is going to be a busy month, so we have a few different things for you. First off, tomorrow at 12:30 p.m. Eastern Time, FHWA is having a webinar on maintaining minimum pavement marking retroreflectivity in announcement of the new rules that just were released earlier this month. If you're interested in attending that FHWA webinar, we would ask you to please go and register at the link provided. And again, when I finish wrapping up, I'll put this in the chat pod for you if you want to hold on just a few minutes when we wrap up this webinar. September 15th at 5 p.m. Eastern Time is the deadline for any of you that are going to be applying for the Safe Streets for All grant. And I did post the link there for you as well. Dana, I believe the slides are moving. If you could please move us back to the end. Additionally, for you, another date is September 19th through the 23rd is National Roundabouts Week. You can find more about that on FHWA's website, and they would love to have your support that week and using hashtag Roundabouts Week for any information that you may put out that week. And in so doing, we will be hosting a Roundabouts webinar on September 20th, and we'd love to have you all there. It will be held from 1 to 2:30 p.m. Eastern Time. We will be sending out the registration information for that webinar here shortly. You can also find it once it is open on our website at ruralsafetycenter.org under our Safety Center registration page. That registration should open here within the next week. Again, just a reminder for all of you that we will be putting out certificates and the CEU forms here for all of you within the next couple weeks, so within 2 to 3 weeks if you attended at least 75 minutes of today's 90-minute webinar. Additionally, the recording for today's webinar should be up on our website on the new website archive page or webinar archive page within a week as well. And you should receive all of that information in an email that comes out shortly following today's webinar. So I'd like to thank one more time our three presenters, Alyssa Guggenhour, Karen Asplin, and Georgine Geary. I mean, I learned a lot today, and I hope you all did too. I think there was a lot of great questions coming in through the question and answer pod, so thank you for having that back and forth with us, and thank you again to our presenters.